Section 3.3, Zeros of Polynomial Functions. In this section, we're going to focus on the factor theorem, rational zeros theorem, number of zeros, and finding zeros of a polynomial function. First, we're going to look at the factor theorem. For any polynomial function f of x, x minus k is a factor of the polynomial if and only if f of k equals 0. So what that tells us is x minus k is a factor if, whenever we do synthetic division, we get 0 as our remainder. Example 1. Determine if x minus 1 is a factor of each polynomial. So for part A, our polynomial is f of x equals 2x to the fourth. Notice that we're missing an x to the third term, plus 3x squared minus 5x plus 7. So we're going to do synthetic division here. And we're going to use 1 out front here. The reason I'm using 1 is I'm taking my potential factor, x minus 1, setting it equal to 0 and solving, or you can think of it as changing the sign. Now I need my coefficients, 2, 0, 3, negative 5, and 7. Remember, anytime we skip a term, like in this case, x to the third, we need to use 0 for the coefficient. Now we're going to do synthetic division and find out what our remainder is. So each time we add down, multiply by 1, add down, multiply by 1. As always, if the video is going too fast, make sure you're pausing the video so you can write everything down. Okay, so we got a remainder of 7. This is not 0. Therefore, x minus 1 is not a factor of f of x. Part B, we're going to do it again with our new polynomial. I want you to pause your video and I want you to determine if x minus 1 is a factor of the polynomial and then restart the video to see my answer. After doing synthetic division, I got a remainder of 0, which means yes, x minus 1 is a factor of f of x. Example 2, factoring a polynomial given a 0. So in this example, we're going to factor f of x into linear factors, and we're told that negative 3 is one of the zeros. So since negative 3 is one of my zeros, the first thing I can do is I can do synthetic division and divide out the factor of x plus 3. Remember, since negative 3 is a 0, I should get 0 as my remainder value. Okay, so at this point, we have to think back to the last section about how to write this as a polynomial. F of x was degree 3, so I'm going to reduce that by 1 and write this next polynomial as degree 2. Okay, so I have 6x squared plus 1x minus 1. I got the 6, the 1, and the negative 1 from synthetic division there at the bottom. And I already knew that x plus 3 was a factor. Remember, if negative 3 is a 0, that means that x plus 3 is the factor. Okay, so I rewrote f of x as 6x squared plus 1x minus 1 times x plus 3. If you did FOIL or the box method here with these two polynomials and multiplied them together, you would get back up to our original function f of x. Okay, so we need to keep going. We need to keep factoring. Now I'm going to focus on the quadratic that I have here, 6x squared plus 1x minus 1. So I'm going to factor that by figuring out what multiplies to a times c, which is negative 6, and adds to b, which is 1. Those two numbers are 3 and negative 2. So now I'm going to rewrite the middle term, 6x squared plus 3x minus 2x minus 1, and then I'm going to factor by grouping. Pull a GCF out of the first two and a GCF out of the second two. So I get my factored form for my quadratic as 3x minus 2 times x plus 1. Now don't forget we have the x plus 3 still up there in orange. That needs to come down as well. So we factored f of x, that cubic up at the top, to be the same thing as 3x minus 2 times x plus 1 times x plus 3. Notice that this example started off with kind of a hint. We were told that negative 3 is a 0 of f. Now you have to wonder, well, what if I didn't know that negative 3 was a 0 of f? How could I still factor f? Well, I'm glad you asked. We're going to use the rational zeros theorem. This theorem says if p divided by q is a rational number written in lowest terms, and if p divided by q is a 0 of f, a polynomial function with integer coefficients, then p is a factor of the constant term and q is a factor of the leading coefficient. Now let's try to unpack that and make it in a little bit more simpler terms. So what that's saying is p and q. P over q is the same thing as our constant term, so the number without x, divided by our leading coefficient. So what we're going to do in this next example, we're not going to be told what one of the zeros of our function is. We're going to have to find possible zeros. And all of those possible zeros we can find by taking our constant term divided by our leading coefficient. Example 3, part A. So we're going to start by listing all possible rational zeros for the function f of x. The first thing we do is find p divided by q, or you can think of it as constant term divided by leading coefficient, which in this case is 2 divided by 6. Now we're going to write out all of the possible factors of 2 on the top in the numerator, and then all the possible factors of 6 in the denominator. Remember, factors are just numbers that divide evenly into 2 and 6. So on the top, the only two numbers that divide into 2 are going to be 1 and 2. So I'm going to have a plus minus 1 and a plus minus 2. The reason I have the plus minus is because 1 and negative 1 divides into 2, and 2 and negative 2 divides into 2. So it's kind of just a lazy person's way of writing 4 numbers more condensed. Next, my factors of 6 are 1, 2, 3, and 6. To get my entire list now, I'm going to need to take all combinations of the numerators divided by the denominators. So let's start by looking at the denominator of 1. If I take each of those numerators and divide it by 1, well, I'm just going to get those numerators again, right? So my first two numbers are going to be 1 and 2. Next, let's look at a denominator of 2. So now I'm going to divide my numerators, 1 and 2, by 2. So the next number on my list is going to be 1/2. And then 2 divided by 2, we know is the same thing as 1, so we're not going to list that again. Let's move on to the denominator of 3 now. So we're going to start with 1 divided by 3, or 1/3. And then we also have 2 divided by 3, or 2/3. Last, we're going to look at the 6. So we've got 1 divided by 6. And 2 divided by 6 is just the same thing as 1/3, which we already had in the list, so we're not going to write it again. For part B, we're going to find all rational zeros and factor f of x by testing each of our possible zeros. So we're going to take from that list, one at a time, a 0, until we find one that works. And by works, I mean we're going to do synthetic division and see which one gives me a remainder of 0. So I'm going to start with -1. So I always like to ask myself, or put the question on the paper, is -1 a 0? So I know what I'm doing. So I'm going to start with putting -1 out here and my coefficients up at the top. and I'm going to do synthetic division. Again, I'm looking to see if my remainder is 0. That will tell me whether or not negative 1 is a 0 of my function. So since I got 8 as my remainder, I know that negative 1 is not one of my zeros. Now let's test and see if 1 is a 0 of my function. And this time we do get a remainder of 0, so we found that 1 is a 0 of my function. Make sure that when you're showing work on homework or a test, that you show each of these zeros that you tried, each of these numbers that you tried. Don't erase your work just because you found that negative 1 wasn't a 0. It should still be shown on your paper. So now that we've found that 1 is a 0, I can write f of x as follows. It's going to be a cubic since I started with a degree 4, and I'm using 6, 13, 1, and negative 2 as my coefficients. So I have 6x to the third plus 13x squared plus 1x minus 2 times x minus 1. Now let's stop and look at that for a second. I just found that 1 was a 0, which means that my factor would be x minus 1. Again, it's because if I set x minus 1 equal to 0 and solve, I would get a positive 1. So now we're going to keep going with the process. We need to find a 0 of my cubic now. Okay, so now we are starting over again with my cubic function in orange right here. And I can still use this list of blue numbers up here. I need to test and see which ones are zeros. I don't need to start back at negative 1 because since negative 1 was not a factor of f of x, I know it's not going to be a factor of one of f of x's factors. But I do, however, need to test and see if 1 is a factor again. Just because I had it be a factor one time doesn't mean that there's not two factors of x minus 1 in my function. So I want you to pause your video and I want you to see if 1 is a factor of the cubic. After doing our synthetic division, we get a remainder of 18, which means that 1 is not a factor. So now we move on to negative 2. Pause your video and see if negative 2 is a factor of the cubic. And we find that negative 2 is one of the zeros of my cubics. So now we have factored down to 6x squared plus 1x minus 1. I got those coefficients from the synthetic division above. X plus 2, I got that because negative 2 is a 0, which means x plus 2 is a factor, and x minus 1, which was my first factor that I found. Now that I have a quadratic left, I don't have to keep testing different possible zeros because I can just factor this. So I'm going to set my x up, what multiplies to negative 6 and adds to 1, factor by grouping. So we get 3x minus 1, 2x plus 1, and then don't forget the x plus 2 and the x minus 1 from above. So what we've done so far is we have factored f of x, this polynomial up here at the top, into these 4 factors. Now that we've factored, we can use the zero product property and say that we can just set these equal to 0 and solve in order to see what they're equal to. So if I set each of those equal to 0 and solve, I get 1/3, negative 1/2, negative 2, and 1, which you'll remember, all of those were in our list of possible zeros. We just had to figure out which ones were the actual zeros of f of x. Quick side note, once we got down to our quadratic in that last example, we were able to factor it. But if we weren't able to factor it, if nothing would have multiplied to negative 6 and added to 1, then we could have just used the quadratic formula to find the 2 zeros for the quadratic. Let's start by talking about the fundamental theorem of algebra. This theorem says every function defined by a polynomial of degree 1 or more has at least one complex zero. Remember, complex means a number that has an I in it, an imaginary number. Number of zeros theorem. A function defined by a polynomial of degree n has at most n distinct zeros. So that tells us if we have a cubic function, which is degree 3, we should expect to have 3 zeros. Example 4. Find a function f defined by the polynomial of degree 3 that satisfies the given conditions. So since we are degree 3, we should expect to have 3 zeros, which we do. We have zeros -1, 2, and 4. We also know that f of 1 equals 3. We'll use that fact at the end. So first of all, let's start with our zeros. If I know that -1, 2, and 4 are my zeros, I know that the factored form of function f should be x plus 1 times x minus 2 times x minus 4. Because if I set each of these equal to 0 and solve, I would get the list of zeros in the problem. So now I'm just going to FOIL the first two together. You could also use box method. Combine like terms. And then FOIL these two together and combine like terms. Once we've found x to the third minus 5x squared plus 2x plus 8, we're now going to use the fact that f of 1 equals 3. So this cubic that we found here does have zeros of -1, 2, and 4, which is what we wanted, but we don't necessarily get out 3 when we plug 1 in for x, which is what this fact says right here. So my answer could be any multiple of this cubic. So maybe I need to multiply everything in this by 2. That would still have the same zeros, and then maybe it will give me out 3 when I plug in 1. We just need to find what factor that is that we need to multiply it by. So here's the fact that we're using now. I'm going to set 3 equal to some value a times my polynomial with 1 plugged in. So let's look at that one more time. I'm plugging 1 in for x, because that's what f of 1 means. I want to get out 3, and I'm trying to figure out what I need to multiply my whole polynomial by, this a, in order for that to work out. So I'm going to put this right part in my calculator, or just evaluate it, and we're going to get 3 equals a times 6. So solving for a, I'm going to divide both sides by 6, and we get a equals 1/2. So we find the final answer for our polynomial to be the cubic that we found, but I have to multiply 1/2 by each of those terms. So I get f of x equals 1/2 x to the third minus 5/2 x squared plus x plus 4.